You know what's the strangest thing I've ever thought about? That you could have a picture in your head, a completely wrong picture of how the universe works, and every single experiment would still agree with you. Every number, every prediction, perfect. You'd never know. Now that should give you chills, because it means reality is deeper than any story we tell about it. And we're just here, trying to catch it. So let me tell you about two theories. Usually people say that in science one should pay, one doesn't know how to distinguish them. And that's right. However, for psychological reasons, in order to guess new theories, these two things are very far from equivalent, because one gives a man different ideas than the other. By putting the theory in a certain kind of framework, you get an idea what to change, which would be something, for instance, in theory A that talks about something that you say I'll change that idea in here, but to define out what the corresponding thing is you're going to change in here may be very complicated. It may not be a simple idea. In other words, a simple change here makes maybe a very different theory than a simple change there. In other words, although they're identical before they're changed, there are certain ways of changing one which look natural, which don't look natural in the other. Therefore, psychologically, we must keep all the theories in our head, and every the theoretical physicist that's any good knows 6 or 7 different theoretical representations for exactly the same physics, and knows that they're all equivalent, and that nobody is ever going to be able to decide which one is right at that level, but he keeps them in his head hoping that they'll give him different ideas for guessing. Incidentally, that reminds me of another thing, and that is that the philosophy or the ideas around the theory are a lot of ideas you say I believe there is a spaceme or something like that in order to discuss your analysis, that these ideas change enormously when there are very tiny changes in the theory. In other words, Princess Newton's ideas about space and time agreed with experiment very well. But in order to get the correct motion of the orbit of Mercury, which was a tiny difference, the difference in the character of the theory with which you started was enormous. Reason is these are so simple and so perfect. They produce definite results. In order to get something to produce a little different result has to be completely different. You can't make imperfections on a perfect thing. You have to have another perfect thing. So the philosophical ideas between Newton's theory of gravitation and Einstein's theory of gravitation are enormous. Their differences rather are enormous. What are these philosophies? These philosophies are really tricky ways to compute consequences quickly. A philosophy, which is sometimes called an understanding of the law, is simply a way that a person holds the laws in his mind so as to guess quickly at consequences. Some people have said, and it's true, for instance, in the case of Maxwell's equations and other equations, never mind the philosophy, never mind anything of this kind, just guess the equations. The problem is only to compute the answers so that they agree with experiment, and is not necessarily to have a philosophy or argue or words about the equation. That's true in a sense, yes, and no, it's good in the sense you maybe if you only guess the equation, you're not prejudicing yourself, and you'll guess better. On the other hand, maybe the philosophy helps you to guess. It's very hard to say. For those people who insist, however, that the only thing that's important is that the theory agrees with experiment, I would like to make an imaginary discussion between a Mayan astronomer and his student. The Mayans were able to calculate with great precision the predictions, for example, for eclipses and the position of the moon in the sky, position of Venus, and so on. However, it was all done by arithmetic. You count numbers, you subtract some numbers, and so on. There was no discussion of what the moon was. There wasn't even a discussion of the idea that it went around. There was only calculate the time when there would be an eclipse, or the time when it would rise, the full moon, and when it would rise half moon, and so on. Just calculate it only. Suppose that a young man, Glender the astronomer, said, I have an idea. Maybe those things are going around, and there are balls of rocks out there. We could calculate how they move in a completely different way, and just calculate the what time they appear in the sky and so on. So of course the Mayan astronomer would say, yes, how accurate can you predict eclipses? He said, I haven't developed a thing very far, he says, but we can calculate eclipses more accurately than you can with your model, and so you must not pay any attention to this because the mathematical scheme is better, and there's very strong tendency of people to say against some idea. If someone comes up with an idea, says, let's suppose the world is this way, and you say to him, well, what would you get for the answer for such and such a problem? And he says, I haven't developed it far enough. And you say, well, we have already developed it much further, and we can get the answers very accurately. So it is a problem as to whether or not to worry about philosophies behind.